All right, number 24, simplifying complex fractions. I prefer to write this out a different way. I'm going to write this out as x squared minus 2x minus 8 over x minus 1. And then this means divided by the bottom, which is just 5x minus 20. I'm going to turn that into a fraction as well. I'm going to factor everything that I can. So this is going to end up being x minus 4 times x plus 2 all over x minus 1. And then I'm going to, might as well do two things at once. I'm going to change this to division. I'm going to flip this upside down. It turns into 1 over 5x minus 20, which I'm also going to factor at the same time into 5 times x minus 4. I cancel out what I can. X minus 4's cancel. In the numerator, I'm left with x plus 2 times 1, which is just x plus 2. In the denominator, I'm left with x minus 1 times 5. This would be the answer in factored form, x plus 2 over 5 times x minus 1. But it's also important to understand that your answer might look a little bit different on the final. Maybe you see the actual distributive property and in standard form in the bottom as 5x minus 5. Both of these answers are correct. It just depends on what one of the four choices looks like. Number 25, simplifying this fraction is kind of similar to the other one in that you have a single term in the denominator. So you can just divide each part, the 9c to the third by 3c, and then minus 12c to the second over 3c. 9 divided by 3 is 3. C to the third power divided by c to the first is c to the second. Minus 12 divided by 3 is 4. C to the second over c to the first is just c. So that would be your answer, 3c squared minus 4c. Using synthetic division to solve requires you to understand that process with the rectangular box. You take the divisor, whatever number you see here, you use the opposite of that number and put it here, -4. This polynomial must be in standard form, meaning that the highest exponent must start at the largest and work its way down to the constant. You can't ever skip a variable, meaning if this wasn't here and it just went from x to the third down to 3x, you would have to put a placeholder of 0 in for the x squared spot. But we have x to the third, x to the second, x to the first, and then a constant, so we don't have to worry about any placeholders. What you do is you put the coefficients in line right here, and you have a 1, because 1x to the third, a -2, a +3, and then a -22. The process is, whatever this number is, you write it right here. You then multiply -4 times 1, put that here. You then add straight down. -2 plus -4 is -6. You do it again. -6 times -4 is +24. You add straight down, you get 27. Okay, then you do this process again. You multiply 27 times -4, that's -108. You then add straight down, you get -130. When you have these answers, you then have to interpret them correctly. The number all the way to your right is always the remainder. The number to the left of the most right number is always the constant. Then it's x to the first power, then it's x to the second power, then it continues on if you have more numbers left. So our answer will be 1x to the second power minus 6x plus a constant of 27, but there is a remainder here. Because this is not 0, we have to interpret what the remainder is. Because it's a negative number, you would put a minus sign. The 130 is the numerator of whatever the original entire divisor is, which is x plus 4. Simplifying fractions requires you to have like denominators. 27 is good because both of the denominators are 20. So because they're both 20, I know my answer denominator is a 20. We take the numerators and add them. 8x plus 4x is 12x. Be careful because it's very possible this is one of the four choices that are available to you on the final. You must follow the directions, which are simply simplify, but you have to make sure you reduce your answer as much as possible. You can divide 12x and 20 both by 4, which reduces this down to 3x over 5. Now, 28 is a very difficult simplifying a subtraction problem, you have to first realize in order to subtract or add fractions, the denominators must be the same. The denominators are clearly not the same. They're polynomials. So the first thing you're going to want to do is factor the polynomials in the denominator. X plus 1 stays, but x squared plus 4x plus 4 factors into x plus 2 times x plus 2. 2 stays, x squared minus 4 factors into x plus 2 times x minus 2. Look at what the denominators share in common. You're not going to want to multiply because these polynomials are already long. You're not going to want to multiply one by the other because it's going to be too much stuff. This first one has 2x plus 2's, whereas the second one has only 1x plus 2 and an x minus 2. What we can do is just multiply the first fraction by x minus 2 and the second fraction by x plus 2, and then they'll all share the same stuff. So what I'm going to do is take this first fraction, multiply everything by an x minus 2, and the second fraction, multiply everything by an x plus 2, and then they will share the same denominator components, 2x plus 2's and 1x minus 2. So we have to simplify a whole bunch of stuff. I know that when I have the same denominator, my denominator stays the same. So I can go ahead and make this into one single fraction. It's going to be 1x minus 2 and 2x plus 2's. My numerator is going to be whatever this is, x minus 2 times x plus 1, minus whatever this is, which is going to be 2 times x plus 2. I suggest simplifying that part on the side. So x minus 2 times x plus 1 minus 2 times x plus 2. I probably would just get rid of this polynomial here by foiling it. X squared plus x minus 2x minus 2. And let's just simplify that by combining these like terms. 1x minus 2x is negative 1x. And then I can use the distributive property here, multiply everything by negative 2 and add it to the bottom of this, or the back of this. Negative 2 times x is negative 2x. Negative 2 times 2 is negative 4. Then I can combine like terms here. X squared has no other x squareds to combine with, so that stays that. Negative 1x minus 2x is negative 3x, and negative 2 minus 4 is negative 6. So my numerator, when I simplify this whole mess here, ends up being x squared minus 3x minus 6 over the denominator, which is x minus 2 times x plus 2 times x plus 2. Next thing you should do is look at the numerator and ask yourself, can I factor this? Because sometimes you do, and it will be an x plus 2 or an x minus 2, which will cancel out with something in the denominator. In this case, there are no numbers that multiply to be negative 6 and also add to be negative 3, because the factors of 6 are 1, 6, and 2, and 3. You're not going to be able to factor this one, which means the answer is just that. Okay, solving equations with fractions. Your whole goal in solving an equation that has fractions is to get it to probably look like a proportion. That's like one of the things you can do. So in order to get this to look like a proportion, which is a single fraction equals another single fraction, we have to take these two fractions here and add them together. To add them together, they have to have the same denominator. This one has a denominator of x, this one has a denominator of 2. We can easily multiply this one by 2 and this one all by x to get the same denominator of 2x. So 2 times 4 is 8, 2 times x is 2x. 7 times x is 7x, 2 times x is 2x. Rewriting the rest of the problem, it looks like this. We now can add these two fractions to the left together. 8 plus 7x, I'll write that in standard form, is 7x plus 8 over a single 2x equals negative 3 over x. Now that I have this in a proportion, I can cross multiply to solve for x. Our whole goal in solving an equation is solving for the variable, or solving for the variable, which makes the equation true. So I multiply 7x plus 8 all by x. Instead of showing the distributive property, to save time, I'm just going to multiply 7x by x, turns into 7x squared, 8 by x turns into 8x. And then on this side, 2x times negative 3 is negative 6x. We need to solve this equation. In order to solve an equation, you have to differentiate between like simple equations and then more complex equations. Because this has an x to the second power, this is more complex, meaning we're most likely going to have to factor. In order to be able to factor, our equation has to equal 0. So I move the negative 6x to the other side by adding it to both sides, and I'm left with x squared plus 14x equals 0. I then factor by taking out a 7x from both terms. I'm left with an x plus 2 inside the parentheses. I then can set both of these equal to 0. 7x equals to 0 and x plus 2 equals 0. I solve, divide both things by 7. I get 0 as an answer. Subtract both things by 2. I get negative 2 as an answer. But hold up. We know that once we got into this section, there are sometimes going to be situations where an answer that you algebraically get does not actually work. This is exactly the time that this happens. You have to take your answers that you get, replace them back into the original problem up here, and make sure it works. When I put 0 in for x here and 0 in for x here, it does not work because those two spots you get an undefined or you get error. So this will not work for x equals 0. X equals 0 is considered to be extraneous, which means you won't even include it in your answer. The only answer would be negative 2 for number 29. For number 30, this one's easier than 29 because it's already set up, ready to cross multiply. So we would multiply 2 times x minus 3 and get 2x minus 6, and 3 times x plus 1 to get 3x plus 3. We have a simple equation here, meaning we don't have any x squared, so we don't have to factor. So when you're solving a simple equation, move the single x's all to one side, move the constants to the opposite side, and you get your answer. X equals negative 9. You can always check your answer by replacing your number back in for x to make sure it works. Okay, varying directly or inversely. So when it's something direct, y varies directly. You got y equals whatever this is. The cube of x is x cubed. So that's your answer for 31. Inverses, though, are 1 over whatever it is. So s varies inversely would be s equals 1 over whatever this is, which is the square root of t. Okay, 33. We're starting to get to some problems that don't require as much algebra. So these are like calculator questions, evaluating the radicals. Put this in your calculator. It's going to give you 18. Okay, next page. We have a bunch of these calculator problems. So you're going to just put these all in your calculator. Remember, when you're using your calculator, you can get to the square root by doing second x squared, and you get to cube root or any other root you need by hitting the math button. So this is going to equal negative 32. Plus or minus, don't get confused with that symbol, just means the positive and negative version of whatever this is, which is going to be plus or minus 7. Cube rooting a negative number does work. Put it in your calculator to verify. It's negative 2. Putting 37 in your calculator just like you see it, you're going to get 4. Okay, and then this last one, 38, the fourth root, as long as you put this in exactly the way that you see it, it's going to give you 2. So 38's answer is 2. All right, another couple of quick questions, taking radicals and putting them into rational form. So 39, we have x to the power of 4/3, a to the power of 2/5, and y to the power of 5/6. It's really important just to memorize that this number here is your numerator of your fraction, this number here is the denominator of the fraction, and this number here is the base of the exponent. All right, finding the domain of functions. We already saw a domain problem earlier in the review. It was a fraction function. This is a square root function for number 42 and a cube root function for number 43. We know that when you take the square root of a number, in order for it to be a real number, the number on the inside must be positive. All right, you can't actually take the square root of any negative number. You can take the square root of 0, it'll just be 0, but it has to be positive, it can't be negative. So look at the inside, 5x minus 6. 5x minus 6 cannot be negative. Negative numbers are numbers that are greater than or equal to 0. So it has to be positive. It has to be greater than or equal to 0. You can't have a negative number, which would be anything less than or equal to 0. So we solve this inequality. Add 6 to both sides. 5x is greater than or equal to 6. Divide by 5, and you get 6/5 as your answer, or 1.2. So the domain is anything greater than or equal to 1.2, or anything greater than or equal to 6/5. That would be your domain. You can always use your graphing calculator as well. In your y equals screen, put in the actual function, hit graph, see what it looks like. You'll see that the graph starts a little bit more than 1. So that'll give you a good idea about like what the domain would be, what the x values would be. You can also use your table to see where the errors occur. Now, if you use your graphing calculator to see what this picture looks like, you'll see the graph goes on forever in both directions. Every time you have an odd roots always have the domain of all real numbers. So there's really no math that's required here for this type of problem because the cube root has a domain of all real numbers. Every root that is even, like 2, root 2, which is square root, root 4, root 6, the domain has, like the stuff on the inside has to be greater than or equal to 0 because it can't be negative. But anytime it's an odd number, the domain is everything. Use your graphing calculator to just verify to make sure. All right, this should say directions. For the next part, the directions are simplify the radical expressions. So you have to be very careful and look to see that you are dealing with the correct root. So for number 44, this is a cube root. So you are basically thinking about the perfect cubes. The first thing that I did is I just saw if 216 was a perfect cube itself. So I put the cube root of 216 in my calculator and I saw that it equals 6. So I was like, okay, cool. So I can take that out at least. And then for variables, I like to split up the variables into groups of 3. So x to the 6 is x to the 3rd times another x to the 3rd, and y to the 9th is y to the 3rd, y to the 3rd, and another y to the 3rd. You can cube root anything that's being cubed. The cube root of x to the 3rd power is going to be an x. It comes outside of the root of the symbol. We can cube root this one as well. We're left with another x, which will turn us into x squared. We can cube root all 3 of these. It'll turn into y times y times y on the outside. So this answer would end up being 6x squared times y to the 3rd power. Number 45 is a square root. Now we're dealing with perfect squares. 32 is not a perfect square. However, it has a perfect square factor. It's 16. So I rewrite it as 16 times 2. And I personally really do like just splitting everything up into groups of 2 and whatever else is left to make it still equal. X to the 5th is the same thing as x squared times x. Y to the 4th is y to the 2nd times y to the 2nd. Z to the 3rd is z to the 2nd times z. Everything I'm underlining, you can square root and bring it outside of the symbol. The square root of 16 is 4. The square root of x squared is x. The square root of another x squared is another x, which brings us to x times x, which is x squared. The square root of this y squared and this y squared will both be y, so you'll have 2 y's here, y to the 2nd power, and then you'll have 1 z left because of the z squared. Everything I'm circling stays inside of the symbol because those things cannot be square rooted evenly. So you have the square root of 2xz still inside. So this would be your final answer. Number 46 is an application problem. We know that a squared plus b squared equals c squared in right triangles. So we are trying to find the c, which is the hypotenuse. What I would do here is take the legs 8 and 12, square them separately to try and find what c is equal to. Well, 8 squared plus 12 squared is 208. So we get 208 is equal to c squared. To solve for c, you would square root it, and we're left with the square root of 208, which is not a perfect square. It has a perfect square factor. It's 16. So I'll rewrite it as 16 times 13, knowing that I can square root the 16 into a 4, and I'm left with 4 times the square root of 16, or sorry, square root of 13. All right, and last two on this page, 47 and 48, simplifying radical expressions. Radical expressions work like variables in that if you have the same exact variable, you can combine like terms. If you have the same exact radical, you can combine like terms. Square root of 5, square root of 5, square root of 5. They're all the same type of radical, same root, same radicand. So you add them all, subtract them all, whatever the case is. You add or subtract the coefficients. 6 plus 3 is 9, 9 minus 2 is 7. So this is 7 times the square root of 5, or 7 root 5. All right, and then for 48, these are not all the same, but we have like terms. 5 cube root of x minus 3 cube root of x can be combined together into 2 cube root of x, and then 4 square root of x plus 5 square root of x would be 9 square root of x. Again, and that order could be different on the answer key for the final. The order might be in the opposite, which is fine.